So section 7.3 is about solving equations using multiplication and division. Our essential question is, how can you use multiplication or division to solve an equation? So this is the exact same setup as the last section, only this time we're using multiplication and division rather than addition and subtraction. To start off, we have a couple key ideas. The first one is the multiplication property of equality, and the second one is the multiplicative inverse property. So the first property is the multiplication property of equality. So what that means in words is when you multiply each side of the equation by the same non-zero number, the two sides remain equal. A number example would be like this: 8/4 equals 2. So we would recopy down our 8/4, and this time you're going to multiply it by a number that's going to eliminate, or basically do the opposite. Remember the inverse operations. Okay, so we're dealing with this as division. We're doing the inverse operation of multiplication, and what that equals is 2. That's our same 2 that we used. Do the same thing to this side of the equation. Multiply it by 4. So as you can see, I took this as a division problem and I did the inverse operation, which is multiplication. I multiplied it by 4. And I have to do it over there. What ends up happening is, if you think about it, this actually turns into over 1, right? And then I can get rid of this, I can get rid of this, it becomes a 1 and a 1, which in turn gives me 8. 2 times 4 equals 8. So that's where I get that 8, that's where I get this 8. So I used a number right here, I used 4, so that I could get rid of those 4's and keep my 8 by itself. Algebraically looking at it, it would look like this. And this is something that you'd see in homework. So I keep my x over 4. I'm going to actually multiply, let me write out my, there we go. Here's my equation. Sometimes I like to kind of do it like this. So I'm going to multiply this side by 4. I'm going to do the same thing over here. So what that ends up doing is, you could do a little bit of side math, and you could say 4 times x over 4 would in turn just be 4 over 1. I can do some cross factoring, 1 and 1, which just leaves me with x. X equals 2 times 4, which is 8. So my x is equaling 8. And as you can see when we did the numbers, I'm going to bring my math over here real quick. I'm going to take my 8 and I'm going to fill it in for what I had. I had 8 over 4 equals 2. How many times can 4 go into 8? Go in there 2 full times. So yes, it does check. The other property we're going to deal with is a multiplicative inverse property. And what that means is the product of a non-zero number n and its reciprocal, which would be 1 over n, is 1. In numbers, it looks like this. So if we had 5 times 1/5, it would equal 1. If you actually did that out and we looked at it, 5 over 1 times 1 over 5, our 5's could cross factor out to be 1 and 1, equals 1 over 1, which we all know equals 1. Algebraically, it would look the same if I had n times 1 over n, because that would be the reciprocal of just n. It would equal 1 over n times n, which equals 1. So n cannot equal 0. Okay, don't let that get you really confused, because remember that inverse operations undo each other. So multiplication will undo division, and division will undo multiplication. Don't forget that. Example 1 is solving equations using multiplication. Given this problem, they're telling you to solve it. So we have to think about what we have to do. Our first thing is to write out the equation So it's W over 4 equals 12. Then we use the multiplication property of equality and we undo the division. Let me get my pointer. Okay, when we have a division or a fraction sign like that, that actually means division. So I'm just going to make a little note of that right here. Fraction bar, and we should know this. Fraction bar means division. That's really key to know as you're doing this. So to undo this division, we have to use multiplication. So we're going to multiply this side by 4 because that's, remember, I want to get W all alone. And in order to do that, I've got to get rid of my 4. So even if I were to set this up to do a little bit of side math over here, I would do 4 times W over 4, which would just look like this. Cross factor out my 4's and get 1, so 1 times W is W. 1 times 1 is 1, which we all know equals W. So there's my side math proving that now I've gotten it down to just W on this side. But remember, whatever you do over on this side of the equation, on the left side of the equal sign, you have to do over on this side. So I have to multiply by 4 again. So 12 times 4 is 48, and that's as simplified as I can get. Don't forget to do your check, because a lot of times in the test or a quiz or something, it's going to tell you to check it. So now if W equals 48, I put in 48 over 4 equals 12. How many times does 4 go into 48? 12 times. Does 12 equal 12? Yes, there's my check. Okay, the next one is 2/7 times x equals 6. First step is to rewrite the rewrite the equation so it's out of the way. You are all rewriting this. This is literally the steps you'll take to actually show work. I want to get rid of my 2/7 because I have an x there. Now remember in the last one we had a W on top for a numerator, but this time we have 2/7. So you have to do a little bit of extra work here to figure this out. What would be, what could I use to actually get rid of 2/7? Well, in the multiplicative inverse property, the product of a non-zero number n and its reciprocal, 1 over n, is 1. So let's multiply it by its reciprocal. Will that get me to 1? So now I'm left with just x. Well, I can cross factor out those and get a 1. I can cross factor out those and get a 1. 1 times 1 is 1. 1 times 1 is 1. So that leaves me with just 1. Now remember, I can say I have 1x equals, my other side. But in turn, we really don't need to put that 1 there because we know if we have 1x alone, we can just leave it as x. Okay, so don't forget the most important thing. You have to also multiply or divide whatever you're dealing with, or adding or subtracting, to the other side. We use 7/2, the reciprocal, right? So now I'm going to do a little bit of side math. I'm going to do 6 over 1 times 7 over 2. I can do a little bit of cross factoring. 2 goes into 2 one time. 2 goes into 6 3 times. So now I'm left with 21 over 1, which equals 21. So now my answer is x equals 21 because I just took this and I solved it over here with my side math. So my answer is x equals 21. Now you just check it. So just fill in, what did I have? What was x? Well, if I've got 2/7 times 21, does it equal 6? So again, you just check it out. Does it work? Put 21 over 1. Can cross that out, cross that out. Now I have 6 over 1. Yes, it works. Okay, for our last key idea, we've only got one more example after this, and then we're done with this video. But we have the division property of equality. So basically we're talking about the same thing as the multiplication property of equality, and it says when you divide each side of an equation by the same non-zero number, the two sides remain equal. So looking at this in numbers, we have 8 times 4 equals 32. Okay, that makes sense. If we took and we said 8 times 4 and we divided out the 4, it would equal 32, and we would divide out the 4 over here. So what I'm doing differently is I'm taking this and I'm doing the same thing over here, and what it would do is leave me with, sorry, I'm changing colors here, it would get rid of the 4's over here and it would leave 8. 32 divided by 4 is 8. Okay, 8 equals 8. Algebraically, it would look like this. So if I had 4x equals 32, we have 4 times x technically, right? If I just put a little dot in there. We could divide out our 4. Remember what I said last time is that fraction bar represents division. Could divide out 4, do it over here, and do it on both sides. Because I can move these and cross factor them, it'd be 1 and 1. It would leave me with x equals 32 divided by 4 is 8. Now just check your work really quickly. Is 4 times 8, does it equal 32? Yeah. 32 equals 32. Okay, so here's an example. We're solving an equation using division this time. Rewrite your equation. That's a b, not a 6. So 5b equals 65. All I'm going to do is I'm going to divide out my 5 from this side. So whatever I do over there, I'm going to do over here. When I divide these out, I'm left with 1 and 1. 1 over 1 equals 1, so it gives me 1b, or just b. 65 divided by 5. Again, if you have to do your side math for this, go for it. But 65, and you would write it just like this, 65 divided by 5. 65 divided by 5 equals 13. And that becomes what my solution for b is. So this would be your answer, and then to check it, you would just say 5 times 13 equals 65. 65 equals 65. And it checks. So because I'm not very far into the video, I want to do a quick recap, and then I'll give you your practice problems. So this won't take long, but I'm going to do, I'm going to do 4 separate problems where I'm going to actually, we're going to do one with addition, one with subtraction, one with multiplication, and one with division, just so you kind of have a recap over 7.2, 7.3, because they're very similar. So these 4 problems, if you want to try them on your own right now, see how you do, and then come back and check the work as I go, you might want to. These are 4 more challenging problems than the ones that we had been working on, so I think this is good practice before you actually do your practice problems. So this first one, starting with when we have this subtraction sign right here, that means that we're going to want to get rid of our the number 2 and 5/10. To get rid of it, we simply add 2 and 5/10 to it. Remember me showing the number line. If you are taking a negative number here and you're adding a number to it, you can potentially get to 0, which is what we're doing in this case. That leaves us with m all by itself. That's knocked out. Now remember, whatever you do to one side, you have to do to the other side. So I'm going to put 2.5 and I'm going to add it over here. 5 plus 2 is 7. Bring our decimal straight down. 2 plus 1 is 3. So our answer ends up being m equals 3.7. And don't forget to do your check with it to make sure that that's correct. But I'm going to stop there not to take up too much more time. The next one we're going to be using subtraction. So we want to get rid of our 2/3. In order to do that, we have to subtract 2/3. And again, we're going to do the same thing over here. We're going to subtract 2/3. So you have to do a little bit of side math. Obviously in this one we know it's going to be 0. So that's where we get our x all by itself. But you're going to do your side math over here. So So I'm going to do it down here. We have 9/10 minus 2/3. Don't forget, we have to find a number that the bottom can both go into. I'm just going to use 30. Because remember, adding and subtracting takes a little bit more time with fractions. Let me finish this one up for you and give you the answer. So all I did here was multiplied all my numbers. That's not a 6, that's a 0. To get my new numbers on top. All I do is go straight across. 27 minus 20 gives me 7/30. And that cannot be reduced again because we have a prime number. So x ends up equaling 7/30. You can do your check to make sure. So this multiplication one looks a lot harder than it actually is. You need to actually rewrite this problem, and you're going to rewrite it to look like this. 24 equals 3/4 times r. This is just throwing you off. If you ever have a variable like that, you can always just say the fraction times the variable. So let's pretend that's it. It's completely 3/4 times r instead of 3r divided by 4 is what they're telling us up there. Okay, so we're going to do the opposite. We're going to actually multiply the reciprocal of 4/3. And you're going to do the same thing over here. And what that does is, just to kind of show you a little bit of on the side here, we're just taking 3/4 and we're multiplying it by 4/3 so that we can get rid of that entirely and have r to itself over here. So again, rewrite it with the variable next to it. We can see that we're multiplying the 3/4 times the r. We want to get rid of 3/4, so we're doing the opposite of the 3/4 division, and we're timesing it by its reciprocal. So do the same thing over on the other side. Your other side math, if we have 4/3 times 24/1, you can just cross factor those out. 3 divided by 3 is 1, 24 divided by 3 is 8. Multiply straight across, we should get 32/1, which ends up equaling 32. And again, put that into place now. Take your r and make it times 32. See what you end up getting. 32 times 3 divided by 4 is at 24. And that's how you can check it. Alright, so on the division one, they're kind of fooling you again. Normally, we would see it written like 12.5 n equals 32. So don't get confused when it doesn't actually have that. It's got the multiplication sign in there. You can still divide out your 12.5, and you're going to do the same thing over here. So that eliminates my 12.5 and leaves me with just n. Now the tricky part on this one is to actually divide this out, because you have to do some long division. 32 divided by 12.5. If you have a decimal, you move it over to the right, which in turn is going to move this one over to the right. My decimal goes straight up. Okay, so now you do 125 into 320. That goes in there 2 full times. 125 times 2 is 250. Do out your subtraction. Come up with 70. So hit another 0, bring it down. 125 goes into 700 how many times? And that goes in 5 times. 5 times 125 is 625. You end up with 75 left over. You get another 0 and bring it down. How many times does it go into 750? It goes in there 6 times. And I ran out of room, but it'd be 750, 0. So you end up with 2 and 56 hundredths as your final answer. That's what n equals. So these are a little bit trickier, but they're good practice. So if you can do this, I think you'll be in good shape. If you need additional help, obviously don't hesitate to ask me. And here are your practice problems. Rap J page 162, and that's out of 7.3. You have just numbers 1, 3, and 5 to complete. We'll finish the rest in class.